This is our final evidence, which is called energy sources to power automobiles. First, what are fossil fuels? Fossil fuels come from decomposing plants and materials, and these are found in the Earth's crust, and they mostly contain carbon and hydrogen, which are burned to collect energy. Why are they bad? When these type of fossil fuels are burned, greenhouse gases are released to the environment, which consequently rise temperature levels. This rise in temperature affects all living organisms on Earth, and this phenomenon is called climate change. So we have come with some alternatives to fossil fuels. First, we have the photovoltaic cell. This device is also known as the solar panels, and they are made from two types of semiconductor materials, one with a positive charge and the other one with a negative charge. The main function of these photovoltaic cells is to induce free electrons to move from one semiconductor material to another in search of a hole to occupy. This movement results in a voltage difference and consequently an electric current. The main advantages of photovoltaic cells is that they provide a sustainable and renewable long-term solution to the global energy crisis because they do not emit any type of greenhouse gases. They are accessible and affordable, and properties equipped with solar panels tend to have a higher market value and are more appealing to buyers. They can be affordable and accessible, but it depends on the area where you buy them. And the main disadvantages is that the initial cost may be high. They also need storage and maintenance, and the maintenance needs to be regular. And the impact of the aesthetic of an area may be effective because they are location dependent, because they need sun, and they may look bad in a design.
Okay, so I will be explaining what galvanic cells are. They're made out of two metals and they're separated by an electrolyte. One of these two metals is more reactive, and this makes this metal release electrons, and this allows electric current flow. So I'm going to explain the good things about these type of cells. They do not need any external energy source in order to be powered because the energy of the reaction comes from what is used to make the reaction, which in this case are the metals. So this means that it's spontaneous reaction because there is no external energy needed in order to power them. And it's also low cost and easy to maintain. The bad things about these type of cells is that they eventually run out of chemicals to produce the energy, and there are many factors that can affect it, like its functioning, such as temperature or pressure. And most of the time, the chemicals that are used are a little bit toxic to us, and we need to be careful in the way in which we dispose them. So I'll be explaining what fuel cells are. They also involve an electrolyte like galvanic cells, but in this case we use fuel. And an example of a form of fuel is hydrogen. This is the most eco-friendly one, but it's not so commonly used. And in this case, the electric current occurs when the fuel reacts with the electrolyte. And yeah, electrons start to flow because of this. So I will be explaining what are the good things about this. In the first place, it does not produce as much waste as the other type of cells do because it's not toxic to the environment. It has an easy maintenance, and it only needs hydrogen and oxygen to function. It's expensive to manufacture since it involves using expensive metals for the production. Hydrogen gas is expensive as well. It requires special tanks to be stored correctly, and it's not the most effective. It does not produce as much fuel as it is needed. So I'm going to be explaining now the objectives of this problem situation. So we needed to generate a cell that produced from 2.5. So I will be explaining the objectives and methods that we used in this project. So the objective was to produce a cell that made from 2.5 to 3 volts of voltage, and we needed to choose like 2 half cells that would make this possible from like a list of materials. And we also needed to understand the concepts behind of this, such as, like, as I mentioned, the half cell salt bridge electrodes and standard reduction potential.
So we were given a list of reagents to build a galvanic cell with a desired voltage of between 2.5 volts and 3.5 volts. With the help of a simulator, we were able to determine which reagents will give us a voltage between that specific range. The reagents selected were copper in copper nitrate and magnesium in magnesium nitrate. With this, let's analyze how these two compounds react. The first step is to identify which one is being oxidated and which one is being reduced. In the standard reduction potential table, the compounds are arranged in a way that allows you to determine which as the oxidating agent and which as the reducing agent. Based on the table and observing how these two compounds are organized, we can see that copper is the one that is reduced and magnesium is the one that is being oxidated. We know that in a galvanic cell, oxidation occurs at the anode and reduction at the cathode. Therefore, the anode is magnesium and the cathode is copper. Now, let's express the half cells of this galvanic cell. Magnesium is losing electrons and copper is gaining them. So, the overall reaction is this one. Finally, let's calculate the standard potential of the cell. To do this, we simply look up the value of each individual half cells on the table. For the case of copper, which is being reduced, the value is taken as it is, but for magnesium, which is being oxidized, the sign of this voltage is reversed. By simply adding these two values, we obtain a cell potential of 2.71 volts. Here we have a diagram showing how the constructed cell will look and the reactions that occur in each part of the cell, as well as the video of our laboratory practice where this cell was used to power a small toy.
So here we can see some pictures of the wind energy, the solar energy, and the hydroelectric power. And finally, we are going to talk about our conclusions. An exciting part of this exploration has been putting into practice what we learned theoretically in the lab. Especially, we focus on galvanic cells, where we saw how they work in reality. But we also have explored 3 alternative energy technologies like the photovoltaic cells, the fuel cells, and the galvanic cells. During our experiments, we noticed that a crucial component of the operation of a galvanic cell was the salt bridge. The salt bridge is this part here. And this small element was essential for ions to move between solutions, maintaining charge neutrality and ensuring the cell functions correctly. And also, by measuring the galvanic cell potential, we figure out how well it works and how it's affected by what it's made of and how we set up in the experiment. So that's it for this presentation, for this video. Thank you so much. And here you can find the references. Thank you.